Okay, we're recording now. So, yep. All right. Graph the equation y equals 2x minus 1 using a table of values. Who knows what I mean by that? Isaac, what does that mean? Huh? Yeah. Okay, so if you put, he's saying if you put 0 in for x, 2 times 0 is 0, minus 1, you'd get a negative 1. Okay? If x is 1, 2 times 1 is 2, minus 1 is 1, so 1 comma 1 is on there. If x is 2, 2 times 2 is 4, minus 1 is 3, right? Okay, how many points do we need for this, you guys? You guys know what kind of equation that, what kind of graph that equation makes? Yeah, John, makes a line. How many points do you need to make a line? 2. And we got 3 just to make sure. So we're going to graph these points. 0 comma negative 1 would be right here. 1 comma 1 would be right here. And 2 comma 3 would be right here. And they make that line, okay? So we're going to graph that equation. And there is our line made by that. Any questions? Okay, this is going to lead us into our discussion of what we'll be talking about today. Okay, I want, say that again? Okay, oh yeah, how many are there, you guys? All right, 28 says, to be efficient, gutters should drop 1/4 inch for every 4 feet that they run toward a downspout. What is the desired slope of a gutter? Okay, so should drop 1/4 inch for every 4 feet they run towards a downspout. What is the desired slope for this? Anybody know how to do this one? What's our rise and what's our run? Huh? It's what? 1/4, right? And what's our run? 4 feet. 1/4 inch and 4 feet. Okay? So 1/4 inch is the rise, and the run is 4 feet. Okay, so what does that mean? We got this rain gutter, and it's got to be able to drain, right? So it's got to be going downhill. Isaac. Okay, we could do that. We could make one of them negative because we want it to run downhill. Good. Okay, and what does that mean? How do we explain slope? Okay, say that again. In points. Okay, well, not in points. We define it as rise over run. Remember this? Rise over run. Slope is the, remember yesterday we talked about slope. And what's the rise? Minus 1/4. And the run is 4 feet. The problem is one of these is in inches and one of these in feet. What do we need to do? Make them both in one. Which one would be probably better to put them in? Probably in inches. Why? Yeah, 1/4 into feet would be really, really small decimal, right? So I'm going to change this 4 feet to inches. How many inches is that, you guys? How many? 48 inches, right? Because there's 12 inches in a foot. 4 times 12 is 48. All right, now we need to write rise over run. What is it? What's the rise? Okay, negative 1/4 over the run, which is 48. The problem with this is you got a fraction divided by a whole number, right? And we can make the bottom into a fraction by putting a 1 under it. Does anybody know how to simplify that? Remember doing that when you were younger? You learned how to simplify when you're dividing a fraction by a fraction. You take the top fraction and you divide it by, you times it by the reciprocal of the bottom fraction. What's the reciprocal of 48 over 1? 1 over 48. And if I times those together, I would just multiply the numerators. Negative 1 times 1 is negative 1. And 4 times 48 is 192. And so there is my slope, negative 1 over 192. So if you were doing this in inches, you guys, for every 192 inches you went, you'd have to drop 1 inch. It's not very far, is it? And that's good, because sometimes if you got a long stretch in the front of your house or the back of your house that you're going to put rain gutter, you would run out of space if you had to slope it too much. I remember I was helping when I was building my house. I hired a friend that's a plumber. Paid him by the hour to help me build my house, and we had to put a big long drain pipe from my kitchen sink clear over to where the drain pipe was, which was on the other side of the house. And I was thinking you had to slope it a lot. You know, and I was thinking, man, are we going to have enough to slope this? And he goes, it only has to go 1/4 of an inch for every, I can't remember how many feet he said, but it's probably 4 feet. He probably told me 4 feet because this is probably the correct problem. But, and so 1/4 inch every 4 feet, that's not very much. That's enough to drain out the water out of a pipe. And same with the rain gutter. So there's that problem. Okay, that was 28. What's the next number? Any other questions before we correct it? 16. Okay, so 16. We have the line through 1/2, 5, and we're supposed to find the slope, right? So we have 2 points. 1/2, 5. What's the other one? Help me out, you guys. 2.5, 1. So I want to find the slope through those 2 points. What is it? How do you find the slope? Okay, yeah, we're going to use that formula, aren't we? So Johnny says minus the second y from the first y, or vice versa. I'm gonna take and go 1 minus 5 over 2.5 minus 1/2. So the difference in the y's divided by the difference in the x's. And 1 minus 5 is, okay, negative 4. And 2.5 minus 1/2 is 2. And negative 4 divided by 2 makes negative 2, right? 2 will go into 4 2 times. Negative divided by a positive is a negative. So there's our answer right there. Slope of negative 2. Okay, that one probably looked tough because it had some fractions in it. Okay, are there any other problems you want to go over? Which problems did I assign you? 10 through 24 all, right? Okay, we are going to correct it if you don't have any other questions. In my secondary math 2 class, they know how to identify lines, exponential functions, so linear functions, exponential functions, quadratic functions, okay? In my pre-calculus class right now, they know how to identify every single function you see up there. We call them the parent functions. They can look at an equation and tell what the graph is going to be. Okay? So write this down really quickly. I want you to write this down, you guys. On this equation, y equals 2x plus 1. Notice that y is to the first power and x is to the first power. Anytime both y and x are to the first power, the graph is going to be a line. If you look at this one right here, x is to the first power and y is to the first power. The graph of that's going to be a line. On this one right here, x is to the first power, y is to the first power. So the graph of that is going to be a line. This first one, we have it solved for y, which is the form we wanted in when we're going to graph. These second two, we would have to solve these equations for y so that we would be able to graph them. Or we would need to make a table of values like we did for the bell work today. Okay? Any questions there? All right. Slide number 2. Graph each equation. I want you guys to, like we did for the bell work today, I want you to graph each of these on, just make an XY on an XY thing on your notes, XY coordinate plane on your notes, and then graph each equation individually. Make 3 tables of values. And just remember, you just need 3 points. Two to draw a straight line, but let's just make 3 just to make sure you got the points right, okay? So make 3 points for the first one, 3 points for the second one, 3 points for the third one. I'm going to give you about a minute to do that. All right, let's do the first one. Okay. What's some points you guys chose? You can choose any x points you want. I would choose them somewhere between -10 and +10. But what's the next number you want to choose? Give me one, Chris. Give me 4. Okay, Chris is going to choose 4. If we put 4 into this equation, Chris, what's 2 times 4? +1. 9. Okay, so we're going to graph the point 4, 9. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. Okay, give me another point. Since you guys 4 is almost off the graph, and this one does have a positive slope, I would choose something less than 4. That's 3. I would choose one a little bit away from 4 so you can get a, okay, let's do 1. 1's a good one. So, Jordan, what's 2 times 1? +1 is 3. So we're going to graph 1, 1, 2, 3. Okay, now, could we draw a line through those right now if we wanted to? Yeah, we could. However, let's choose one more point to make sure. Maybe a negative point. -1? Okay, what's 2 times -1? -2. +1 is -1. So we're going to go graph -1, -1, which is right there. Do those look like they're all in a line? Okay, so let's draw the line through them. Okay, good. Let's do the next one in red here. Okay, this next one is the equation 2x minus 4. David, give me a point, x number to start with. 7. Okay, 2 times 7 is 14. Minus 4 is 10. So we're going to graph the point 7, 10. We're going to go over here to 7, up to 10. That one's almost a chart, so I wouldn't pick anything bigger than 7. Isaac, give me another one. 5. Okay. 2 times 5 is 10. 10 minus 4 is 6. So we're going to graph 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. I would get a point down here somewhere because it's looking like it's heading in that direction, doesn't it? Give me, Kayla, give me another number. Okay, let's try 1. 2 times 1 is? Minus 4 is? -2. So we go to 1, -2. All right, there's some points right there. Let's draw those. That line that goes through those. All right, let's do the last one. We're going to do this one in blue. Okay, give me a point. Brooklyn. 0. If I do 0, 2 times 0 is, plus 5 is 5. You guys, I always like to do 0. That's an easy number to do. I would always do 0 if I were you. Okay, 0, 1, 2, 3, 4, 5. Okay, give me another number. Megan. -7? Okay, -7. Megan, what's 2 times -7? -14. If I add 5, what do I get? -9. So let's go to -1, 2, 3, 4, 5, 6, 7, down to -9, which would be right there. One more point, probably in between 0 and -7, right? It's another point I can choose there, you guys. -4. 2 times negative 4 is? Negative 8 plus 5 is? Negative 3. Negative 4. 1, 2, 3, 4, negative 1, 2, 3. Okay, that's it right there. What do you guys notice about all those lines right there? They appear to be parallel, right? Okay, they are parallel. What did we learn last time about parallel lines? What did we learn about parallel lines? Mitchell, what did we learn about parallel lines last time? Huh? That they never cross, but we didn't learn that last time. We already knew that. We learned something about their slopes. What did we learn? Say that again? They're all the same slope. We learned that parallel lines have the same slope, right? So do you think these all have the same slope? Could we count it and find out what they are? What are they? Up 2 over 1, up 2 over 1, up 2 over 1. Every time we go up 2 and over 1, we're back on the line, right? On that one, let's look at this one. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. This one over here, up 2 over 1, up 2 over 1, up 2 over 1. Every time we go up 2 over 1, we're back on the slope, so back on the line. So these all have a slope of 2. Look at the equations. What do you notice? They all have 2x in them, right? Would it be safe to say that maybe that number that's in front of the x might be the slope? Yeah. Okay. Let's go to the next slide right here. Oh, wait. I got to go back to this one. Yes, it would be safe to say that each one of those right here, the number by the x is the slope. Okay? Now, I want you guys to look where each one of these crosses the y-axis. Where does the blue one cross the y-axis, you guys? No, this is the y-axis, the blue, and this thing cross where, you guys? 5. Right there is 5. 0, 5, right? Notice that the blue one was the graph of this one. Notice that that number right there is 5, right there, right? Okay, let's go to the green line. Which one was the green one? It was this one right here. Okay, where does it cross the y-axis? At 1. Notice that number right there on the equation is 1, right? And go to the middle equation, 2x minus 4. That one should cross the y-axis at negative 4. And if you look at the red one right here, it crosses at negative 4. Okay, so guys, we're going to teach you about slope-intercept form of equation of line right here. Everybody write this down. If you solve an equation for y, we get y equals mx plus b. The number by the x is the slope. The other number is where it crosses the y-axis. Okay? Write that down. So you guys, when we have an equation in the form of y equals mx plus b, the number by the x is the slope. The other number is where it crosses the y-axis. Okay? So let's graph this problem right here, you guys. This will help us in graphing a problem. How can we use the slope-intercept form to help us graph an equation? Anybody remember? Say that again, Johnny. Well, what's one point that we know of on the graph right here? Given this equation, you guys, what's one point we know where it's at? 0, negative 3, right? Okay? 1, 2, 3. We know that this graph is going to cross the y-axis at negative 3 because the y-intercept is negative 3. Everybody got that? Now, when you have the one point, you can use the slope to create another point. What is my slope, everybody? 2/3, because the number in front of the x is the slope. So what is that? 2/3. I can go from this point and I can do what? Go up 2 and to the right 3. And that is my line. I can go up 2 more and over 1, 2, 3, and that's another one. Up 2, over 1, 2, 3, and there's another point. Or I can go back to the y-intercept again and go down 2 and to the left 3, and there's a point. Down 2 and to the left 3, Whoops, that wasn't 3, was it? Down 2 and the left 3, and there's another point. And you can continue doing that. And there is that line graphed. I want you guys to be able to graph these. Doing that same thing. You guys ready to try some? Okay. I want you to graph those 4 lines. And this is how I want you guys to do it. I want everybody to have a shoulder partner right here. Elena, is that your name? Elisa. We got another girl named Elena. So, and can you come up here and sit by Dallas right now? And Megan, can you come up here and sit by Chris? And everybody will have a shoulder partner. All right, you guys, I'm gonna graph each one and see if you guys got them right. First one has a y-intercept of 1, because up there on 1, that's the y-intercept, right? Then from there, I'm going to go up 4. 1, 2, 3, 4, and to the right, 1, 2, 3, 4, 5, and put another point. And there is my line, right? Okay, number 2, I'm going to do in black. My y-intercept is -2, so I'm going to go down to -2. I'm going to put a point. My slope is up 5 over 3. 1, 2, 3, 4, 5 over 1, 2, 3. Notice that both of these go up as you move left to right. Did you guys notice that? Yeah. Okay. Then, you go to the third problem. My y-intercept is what, everybody? So -4. I go down to -4, and the slope is -3 over 2. What does that mean? I'm going to go down 3. I got to move this down, don't I? I'm going to go down 3. 1, 2, 3. To the right, 2. Or could have I gone up 3 and to the left 2? Yes, I could do that. And there is that one. Okay? And then the last one. I have a +2 for my y-intercept, so I go up to 2. And then I go which way? Down 1 to the right 5 from there. 1, 2, 3, 4, 5. Or I can go up 1 and left 1, 2, 3, 4, 5. Okay, so there are those. So most of you guys, how many of you already knew how to do this? Or you've been taught it before? So you guys knew it? How many of you haven't been taught it before? Chris, anybody else? Okay, and that's all right. Okay, I want you to graph these 3. And I'm going to help you out right here on this one, on these. But first one, the first one says y equals 3. Is that in slope-intercept form, Gillette? Trey, is that in slope-intercept form, y equals 3? Huh? Is it the slope? Is that the slope or the y-intercept or neither? It's the y-intercept, because really this function right here, if you put it in slope-intercept form, it's saying 0x plus 3, right? Well, the slope is 0, but it still has a y-intercept of 3, so I just go up to 3. There's my y-intercept. And my slope is 0. You guys remember what 0 slope looks like? Not a straight up and down line. It's a horizontal line. In other words, if you'll notice, every single point on that line has a y coordinate of 3. So I can go up to 1, 3, 2, 3, 3, 3, negative 1, 3, negative 2, 3, and so forth, okay? Y equals, no. Y equals 3, that means every y coordinate is going to be 3. So 1, 3, 2, 3, 3, 3. That is a good question. That's the next one, Haley. You got it. You're right on cue. What do you think, you guys? What does that mean? You can't even put this one in slope-intercept form, but say that again, Bailey. Yeah, where's it going to cross the x-axis at? 4. In fact, it's going to be just a vertical line. It has an undefined slope. And every point on that graph has an x-coordinate of 4, like 4, 1, 4, 2, 4, 3. 4 comma negative 1, 4 comma 2, 4 comma negative 3. Okay? Are you talking to me? She's calling me annoying. All right. You might know it, but not everybody knows it. All right. Y equals negative 5. What would that look like, you guys? Yeah. So what, horizontal or vertical? Horizontal line at negative 5. How about x equals negative 6, everybody? Vertical line going through negative 6 of this bottom graph, right? I shouldn't have drawn it up so high. All right, any questions there? Do you guys know how to write an equation for a vertical and a horizontal line? Everybody, I want you to make up a horizontal line and a vertical line that I don't have up here, and I want you to show it to your shoulder partner, and then they're going to show you theirs. I'm going to give you 1 minute to do that. Okay, now you guys, 2x plus y equals 3. Okay, we are going to graph using the slope-intercept form. In other words, this one, before you can graph it, what do you have to do? You have to change it to slope-intercept form. How would you do that with the first one? Yeah, I'm going to rewrite it right here. 2x plus y equals 3. And I've got to get y by itself. That means I've got to get rid of the 2x. So Johnny says that we minus 2x from both sides of the equation. If we do that, 2x minus 2x is 0. So I'm left with y. And I have over here, since these are not like terms, I cannot actually add them together. I can just show the addition by writing negative 2x plus 3. Order of operations says I'd have to know what x is before I can add negative 2 and 3 together, right? I mean the two terms together. Because I'd have to know what x is, times it by the negative 2 before I could add 3. So now it's in slope-intercept form. Everybody graph that. Okay, you guys, y-intercept is what? 3. Now here's a different one right here. All of a sudden now my slope is not rise over run. It's just negative 2. What do I do? Yeah, I put a 1 under it. And so what is that? What am I going to do from there? Down 2 to the right 1. Down 2 to the right 1. Okay, and we graph it. Okay. What would I do to this next equation, negative x plus 3y equals 9, so that I can get it in slope-intercept form? What would I do first? Move the 9 over? If I move the 9 over, then I have all 3 terms on the left side. If I move the y over, then I still have it on the side with the 9. How do I move the x? Yeah, since it's negative x, I'm going to add x to both sides, right? If I add negative x and x, I get 0. So I have 3y equals x plus 9. Okay? Then, what can I do? I can divide everything by 3. Y equals, and by the way, I could leave it like this, but I want to put it in slope-intercept form, so I want to divide 3 into each term. Right now, on the left term, I only have an x, right? It could be x over 3 or 1/3 x. How's that? 1/3 x. And then you have it written in slope, rise over run, the slope and rise over run. And you also not only divide 3 into that one, but you got to divide it in that one. What do you get? 3. 9 divided by 3 is, yeah. And then I write 9. 9 divided by 3 is 3. So now, graph this one. My y-intercept is 3, so I put a point at 3, and my slope, it tells me to do what? Go up 1 over 3, or down 1 and to the left 3, right? And there is my graph. Any questions there? How many of you can do that? Solve equation for x, or for y, put it in slope-intercept form. Okay. Last kind of problem. These are kind of toughies. Okay, this one's a tough problem. It can, this one right here, if you think about it, you can get this one. Graph the line that is parallel to y equals 2x minus 5. Okay, if it's going to be parallel to 2x minus 5, what do we know about it? Yeah, Isaac said it has to have the same slope. What is the slope of this equation, you guys? It's 2, right? So, m equals 2. Now, to put an equation in the form y equals mx plus b, I need to know 2 things. What are those 2 things? I need to know m and b. Well, right now I know m, right? But I don't know b. B is the y-intercept. No, no, because it says graph the line that is parallel to this one. This is a line that our new line is going to be parallel to, but our new line has to go through this point 3 comma 7. It's not 7, because this, if this was the y-intercept, it would be 0 comma 7, and it's not 0 comma 7, it's 3 comma 7. So this is what we're going to do. Any other ideas, though, first? Okay, this is what we would do. We would go and take the equation y equals mx plus b, and we would substitute for everything but b, because we know everything but b, don't we? We know a point on this line. We have an x and a y point, 3 and 7. So what can I put in for y, you guys? 7, because my y coordinate is 7. What can I put in for m, everybody? 2, because my slope is 2. What can I put in for x, everybody? 3, because the x coordinate is 3. And I don't know b. That's what I want to know. All I have to do is solve this little equation for b, and I have it. Okay, what am I going to do to solve this for b? I'm going to times the 2 and 3 together first, and I get 6. I was about ready to write 5. I get 6, and then what do I do to get b by itself? I minus 6, and I get b equals 1. Now am I ready to write my equation, you guys? I have the 2 things I need to know, m and b, right? So y equals, what goes in for m? 2. What goes in for b? 1. And there is the equation. This equation is parallel to that equation. If you graph them, 2x plus 1 would be a line parallel to 2x minus 5. And so you have your equation like that. Could you do a problem like that again? Okay, now let me tell everybody what I'm going to do. Okay, I am going to take a peek. I always put my notes every night. How many of you guys look at the notes when I put them up there for? How many of you ever looked at them before? No one in this entire class has ever looked at the notes? Not even when you missed class? All right. When you guys miss classes, I always put these up there. Plus, if you didn't understand something in class, could you go back and look at this? Yeah. But now, I know, I'm recording this part on purpose. But now I'm going to have a video too. So you can either look at the notes or you can look at the video. Okay? And I'm going to stop this video right now. Okay, last thing is your assignment. Lesson 4-6. This is the last lesson in chapter 4, and then we're going to be reviewing for a test and taking a test here soon. Next week, we're having a test. Yay! Next time you guys come to class, which is which day? Tuesday, we are going to review for the chapter 4 test, and then on Thursday, we're going to take the test. Everybody got that? The last 2 days, we've learned about slope, and we've learned about how to use that to make lines. So, and the stuff before, we were learning about parallel lines and some of their attributes of perpendicular lines and so forth. We'll review it all.